In this video, we're going to look at some information about energy and state changes, specifically dealing with the units involved. So what we want to look at is the different types of ways that these changes of energy associated with states, also known as enthalpies of fusion or enthalpies of vaporization, are given in different units. So sometimes we see kilojoules per mole, kilojoules per gram, and calories per gram. All of these are equivalent to one another, but they're going to have different numerical values because they have different units. But we could interchange between them if we know the substance. So what we're going to look at next is the other part of this that we need, is that we need either the amount of substance. We either need the grams of it or the moles of it. So we can actually have a problem that combines any item from number 1, any set of units, and either one from number 2. So we could be given grams and kilojoules per gram, or moles and calories per gram, or grams and kilojoules per mole, any combination. The key is to look at your units, just like we did with dimensional analysis. It's all about getting your units to cancel out correctly. So what we're going to look at now, is an example. So let's see, we have aluminum at 933 Kelvin, its melting point. And we have 25 grams, and we know that the delta H of fusion is 10.9 kilojoules per mole. Now, this information, the delta H of fusion, would have to be given to you or something you could look up. So if you're working on a sapling assignment and you need to look up a value, that's fine because it's not referenced there. You can look online or look in your book. On an exam, unless you're being asked to calculate the delta H of fusion or delta H of vaporization, you'd have to be given that value, because that value is going to be different for every substance. So now let's look at how much energy is needed to melt this particular sample. And we're going to do it in kilojoules, and we're going to do it in units of calories. So we're going to see two different calculations just as a kind of reminder that you can rearrange or use these relationships to help you get between different units. So we have our delta H of fusion, which has units of kilojoules per mole, and we have our mass of aluminum, which is in grams. So grams is the simpler unit, so that's what I'm going to start with. So I have my 25 grams of aluminum, and we need to think about how we get from grams to moles. Hopefully you're saying molar mass to yourself. So we're going to use the molar mass of aluminum, which is 26.98 grams per mole. Then I can use my delta H of fusion, the value that was given, 10.9 kilojoules per mole. Now I can go through and cancel out the units. I see that grams cancel and moles cancel. What I'm left with is units of kilojoules. And if I do the calculation, I end up with 10 kilojoules. So I do need 2 sig figs, so I'll put a decimal place after that just as a reminder that that 0 is in fact significant. Note that this value is positive because we are dealing with melting, which is an endothermic process. So endothermic processes will always have a positive energy change. Exothermic processes, where heat is being released, will always have a negative energy change. Now let's look at the same problem, but now let's go to calories. So we were given kilojoules per mole, but it's asking for calories. And so we're going to start the exact same way. We're going to get our mass of aluminum. We're going to use our molar mass. Then we're going to use the delta H of fusion that was given in kilojoules per mole. Now we need to go another step. We need to go from kilojoules to joules. So 1 kilojoule is 10 to the third joules. And then I can convert from joules to calories because there's 4.184 joules in each calorie. Now we can go through and cancel out our units. And when we do the math, what we end up with is 2.4 times 10 to the third calories. So the 10 kilojoules and 2.4 times 10 to the third calories are the same amount of energy, just expressed in different units. It's kind of like saying something is kilometers versus miles. It's the same distance, just in a different set of units.